Hi my dear students, in the previous videos we discussed the questions based on the properties of determinants. In today's class again I will discuss some more questions. So already I wrote the question here. So the question is, prove that this determinant value is equals to 1 plus a square plus b square plus c square. Clear? To prove this result my dear students, what I will do, first I will consider this LHS part. And please remember, this question was asked in March 2015 and June 2015 in annual examinations. So second PUC annual examination in Karnataka board examinations, this question was asked. So very important result also. So this result you should remember, because sometimes in CET what happens, I will use these results. In future you are going to use these results. So please remember this result in mind and how to solve the result that now I solve. Clear? So first consider my students. So consider the LHS part here please. So here consider LHS. So what is LHS here? It is a square plus 1 AB CA. Next AB B square plus 1 CB AC BC C square plus 1. So now I consider the LHS, and now I should prove that this result 1 plus a square plus b square plus c square. And what I told to you my dear students, whenever we have the questions like this LHS and RHS, so if the question is of the form prove that or show that, in such cases what should we do? First we should observe the questions. It means first we should think. So what is the RHS we should get? To get this RHS, what are the operations I should apply? First we should think in our mind. Clear? So now my dear students, we can observe here a square plus 1, here AB is there, here AC is there. Here AB, b square plus 1, BC is there. Here CA, CB, c square plus 1 is there. But I require in the RHS part, I should get it as 1 plus a square plus b square plus c square. So what I will do to get that result, RHS part, first I will multiply my difference to this term. If I multiply with a means a into a square plus 1. Here this a will become, I am multiplying a to every element of the row 1. Clear? So that happens a into a square plus 1, and here if I multiply with a means a square into b, and this will become a square into c. And here also to the row 2 I will multiply with b. So if I multiply with b means a into b square, b into b square plus 1, b square into c. To this I will multiply with c square a, c square b, c square plus 1. So that times what happens my dear students, in that case again I get the RHS part easily. To prove that result, first what I will do, I will multiply ABC. Clear? ABC. So this implies here. So I wanted to multiply A to the row 1, B to the row 2, and C to the row 3. So therefore that I am multiplying here, this ABC I wanted to multiply. So for that reason what I will do here, before multiplying A to the first row, B to the second row, C to the third row, I will multiply and divide ABC. Because already we know that in mathematics, if I have any term like this 2x or something, if I have in my students, if this value, if without affecting this value, if I wanted to multiply any constant means what should I do? If I wanted to multiply 2 means, so I will do there this, I will multiply and divide 2. So if you multiply and divide with the same number to the any terms, then value of this 2x will remain as it is. Value to the value, it won't affect. So for that reason, for any expression or for any number, we can divide. If I divide and multiply with the same number, then value won't affect it. So value remains as it is, because these two got cancelled means again you will get 2x only. Like this, to this determinant, without affecting the values of determinant, what I will do, I will multiply ABC and I will multiply ABC and divide. So if you multiply and divide ABC, if this ABC get cancelled means the value will remain as it is, a square plus 1 AB AC, and here it is AB B square plus 1 BC CA CB c square plus 1. My dear students, here to this determinant I am multiplying ABC and dividing ABC. So if this ABC, if I multiply and divide means to this determinant value, the value will remain as this. Value won't change because I am multiplying and dividing with the same number, that is ABC and ABC. So without affecting this determinant, I can write like this: multiply and dividing ABC. I am multiplying ABC because to get the RHS part. So don't worry. So after solving this entire question, then you will come to know why I multiplied ABC and why I divided ABC. And here I multiplied ABC by distance. It means I am multiplying A to the row 1 elements, B to the row 2 elements, and C to the row 3 elements. Clear? Please try to understand what I am doing. So why I am doing that we will come to know after completion of the question. After completion of this question, you will come to know why I am multiplying, why I multiplied ABC only. Clear? So as of now, just understand that to the row 1 I am multiplying with A, to the row 2 I am going to multiply with B, to the row 3 I am multiplying with C. Clear? So this implies 1 divided by ABC I will write as it is. This ABC I will take inside the determinant. It means to the A to the row 1 I am multiplying with A. So here this will become A into A square plus 1, and this will become A square into B, and this will become A square into C. Clear? And now to the row 2 I am multiplying with B. So this will become here A into B square. B, I am multiplying to the row 2 with the element B. So already B is there. So B into B square. A into B square. Here it is B into B square plus 1. And here it is B square into C. B into B square into C. And next here to the row 3 I am multiplying with C. So C into C is C square into A. C square into B. Next C into C square plus 1. So like this we can multiply like this. Clear? Now my dear students, you can observe here. So here in the column 1, here also A is there, here also A is there, here also A is there. So therefore I will take A common from the A. I can take the A common from the column 1, B from the column 2. Here also B is there, here also B is there, here also B is there. It means from the column 2 I can take B common, and from the column 3 I can take C common. So therefore I will write here it is taking common here it is. So take ABC common from column 1, column 2 and column 3 respectively. So I should take the common A, B, C from the column 1, column 2, column 3 respectively. So what happens, my students? Already I have here it is in the denominator 1 by ABC. Already I have outside the determinant. Now if I take A from this column 1 and B from this column 2, C from column, this means again I get ABC. So here it is ABC I am taking outside. So if I take ABC outside, what is remaining here? It is A square plus 1, and here it is B square, and here it is C square, because A I am taking common from the column 1. And now my addition is from the column 2. I will take here it is B. So what is remaining there? So A square, here it is B is common, and B square plus 1, and here it is B common I am taking. So here it is C square is remaining. And next from this I am taking C common. So what is remaining here? A square plus, here it is, and next here it is B square, and here it is C square plus 1. So my dear friends, now you may understood. So clear? I did these operations. So here whatever I did the operations or whatever I did the simplification, that is because of here this step. So here this ABC got cancels. So what is remaining here? It is A square plus 1, B square, C square is there. Here A square, B square plus 1, C square is there. A square, B square, C square plus 1 is there. So now what I do, to the row 1 I add with row 1 plus row 2 plus row 3. If you add all these terms, will get 1 plus a square plus b square plus c square. So therefore easily you can take the common. So therefore I did the like this. I did the steps like this, or the operations I applied here, because to get the 1 plus a square plus b square plus c square. Clear? So now my dear students, this will become here a square plus 1 plus b square plus c square, and here also a square plus b square plus 1 plus c square, and next here it is a square plus b square plus c square plus 1. I am adding all this. Row 1 changes to row 1 plus row 2 plus row 3. This element plus this element plus this element. Clear? And now remaining row 2 remains as it is. That is b square plus 1 into b square, and next c square plus 1. Clear? Now you can observe here, my students, in the row 1 you can take the common 1 plus a square plus b square plus c square, 1 plus a square plus b square plus c square, 1 plus a square plus b square plus c square. I can take the common. So now here it is taking 1 plus a square plus b square plus c square common from row 1. From the row 1 I am taking common. So here it is, this will become 1 plus a square plus b square plus c square. And now what is the inside the bracket element remaining? Here it is, here everything is common. I am taking 1 plus a square plus b square plus c square. It means 1 is remaining, and remaining as it is b square c square. And here also 1 is remaining, and remaining elements as it is b square plus 1 c square. And here also 1, and remaining is b square c square plus 1. Clear? So this is what your here this is from this determinant I can prove the RHS part here, because 1 plus a square plus b square plus c square, this is already I got here, but with this I have the determinant also. Now I simplify this determinant, and in the earlier classes I told to you, whenever you have 1 1 1 in the rows or columns, in that case what should we do? We should subtract the elements, and it means we should make the elements 1 1 1 in whichever row or column you have 1 1 1. In such a row, in that row or column, we should make the elements 0, and that 0 happens if you subtract. Here it is. Here column 2 changes to, I will change the column 2. Column 2 changes to column 2 minus column 1, because 1 minus 1 it will become 0. And even here, another operation I will apply. What is that? Row column 3 changes to column 3 minus column 1. Clear? So if you apply that one, so if you simplify this determinant, you will get the after solving this determinant value, you will get 1, and 1 into this value is your RHS part. Like this we should solve my questions. Clear? So now further I will solve this determinant, and I will get that after solving this determinant I will get that as 1. So easily we can solve further. Clear? So I will erase here. So I will erase this part because I don't have space there. So therefore I will continue here. So what is that? There, my students, I next apply the operation. So the operation here I am applying is column 2 changes to column 2 minus column 1, and column 3 changes to column 3 minus column 1, and therefore that is equals to 1 plus a square plus b square plus c square. Column 1 is as it is 1 b square c square. Column 1 is as it is, but column 2 is changing. How column 2 is changing? Column 2 minus column 1. So this element minus this element, 1 minus 1 is 0, and next this element minus this element, b square plus 1 minus b square. Here it is. This element minus this element, b square plus 1 minus b square plus b square minus b square, got cancels. Again you will get 1. And next this element minus this element, c square minus c square is, here it is 0. And next, my students, column 3 is changing. How the column 3 is changing? Column 3 is changing. Column 3 minus column 1. This column minus this column. 1 minus 1. here it is 0, and next b square minus b square, again here it is 0, and next c square plus 1 minus c square, c square plus 1 minus c square, plus c square minus c square got cancels, you will get 1. So therefore here now we can further simplify 1 plus a square plus b square into c square. So directly my dear students, you can write this determinant value as 1 into 1 into 1, that is this determinant value is 1, because I told you that whenever we have the triangular matrix, clear, the determinant of that is equal, that is multiple of the diagonal elements. So 1 into 1 into 1 is 1. So you can use that result, but in board examinations we don't have that result. As per your syllabus, we don't have that properties. So for that reason, I'll expand along the row 1. Clear? So expanding now, expanding along row 1. So now expand along row 1. So if I expand along row 1 means I should change the sign. So this is plus minus plus. So expanding along row 1. So we will get 1 plus a square plus b square plus c square. This value is as it is. Now the determinant value, we should solve this determinant value. So plus 1 into here it is plus 1 into, leave this column and leave this column and this row. So 1 into 1 minus this element into this element, 0, and remaining element 0 and anything is 0, 0 and anything is 0. So no need to calculate. So leave that one. So this is equals to 1 plus a square plus b square plus c square into 1 minus 0 is 1. So 1 into 1 is 1. So therefore this is equals to 1 plus a square plus b square plus c square, and this is what your required RHS part. Clear? I hope you understood. So still if you have any doubts, you can comment me, I reply for that. And please pause the video to note it down. We'll continue in the we will discuss the next question. That I am going to write now. Yes, my dear students, the next question I wrote here. Prove that this determinant value is equals to x minus y into y minus z into z minus x into xy plus yz plus zx. And this question was asked in March 2017 of your PU board. In the second year annual examination, this question was asked in March 2017. Very important question it is. So now to prove, again what I will do, my dear students, again I will first check the RHS part. So in the RHS part, what I have, I should get in the RHS part as x minus y, y minus z, z minus x. So to get this here is what, which operation I should apply? I apply here is first I will apply row 1 changes to row 1 minus row 2, because if you apply the operation row 1 changes to row 1 minus row 2 means x minus y. One term you can take easily common. And next y minus z. So y minus z means again row 2 changes to row 2 minus row 3. If you apply this, so you will get y minus z and x minus y terms you will get. So for that reason, first what I will do here, first I will consider the LHS. So this I am going to consider the LHS. So LHS here I am taking here LHS. Consider LHS. So what is the LHS here? It is, so consider LHS. So LHS is x square, yz, y square, zx, z square, xy. So this is the LHS I consider. And now my dear students, I am applying the operation like this. Row 1 changes to row 1 minus row 2, because x minus y terms I should get. And even another one operation I am putting here, that I am writing r2 changes to r2 minus r3. Here r1 is changing, here r2 is changing. So you can use the r2 term, because here it is, here r1 is changing. So you can use r2, R2 is not yet changed here. But in this time R2 is changing. So therefore you can apply at a time these two operations you can apply. And now my dear students, this will become here this R1 changes to R1 minus R2. So therefore this element minus this element, x minus y. And next this element minus this element, x square minus y square. And next here is yz minus this element minus this element, yz minus zx. And next this element minus this element, y minus z. And next here is y square minus z square. And next this element minus this element, zx minus xy. And now row 3 is as it is. So z square xy. Clear. Now my dear students, this can be written as this. I can write it as here it is x minus y as it is I wrote. I think we will not have sufficient space, so therefore I will write here only. So this can be written as, my dear students, this I can write it as x minus y as it is I wrote. Next, x square minus y square. We know the formula a square minus b square. So what is the formula we know? A square minus b square is equals to a plus b into a minus b. So this is the formula we discussed in the earlier classes. I mean in the high school level only you learn this formula. So that I am using here. So x square minus y square can be written as, here it is x plus y into x minus y. X square minus y square. A square minus b square can be written as a plus b into a minus b. This formula I wrote here is x square minus y square can be written as x plus y into x minus y. And now here z is there, here also z is there. Can I take z common? If I take z common means what is remaining? Y minus x is remaining. Clear? So from this I am taking z common. Clear? And now my dear students, so instead of taking z common, I will take minus z common, because here x minus y is present, here x minus y is present, but here y minus x is there. If I take minus z means here, if I take z already taking common, and even I am taking minus z. So minus z means here it is minus, here it is minus zx is there. So it means I will write here only x. Minus z into x is minus zx. And next I will write here it is minus, minus minus plus, and y into z. Z is here, so I will write y. Clear? I am taking from these two, I am taking from these two terms minus z, I take the common. I took common. And now here it is y minus z, and here also I can write y plus z into y minus z. Clear? That formula I am applying. And next from this, my dear students, I take here it is, if I take only x, if I take means what happens here is, you can observe here zx minus xy. Clear? You can take it as rough. You can take it as rough work. So what is that? From this zx minus x, where it is yes, zx minus xy, zx minus xy. If I take simply x, here also x is there, here also x is there. If I take simply x common means what is remaining? Z minus y. But I required y minus z. Here also y minus z is there. Here also y minus z is there. If I write this also in the form of z minus y, then easily I can take the z minus y common. For that reason, what I am doing, my dear students, I am taking, instead of taking x, here it is x common, I am taking minus. If I take from this minus means minus x into, here it is minus x into y is minus xy. I am getting minus minus plus z, here it is. So if you simplify this, you will get this part. So therefore here zx minus xy can be written as minus xy. Here it is minus x into y minus z. This I am writing like this. And next the third row I am writing as this, z square into xy. Clear? And now my dear students, you can observe here in the first row, here also x minus y is there. Here also x minus y is there. Here also x minus y is there. It means from the column 1 I can take x minus y common, and from the column from the column row 1. From the row 1 I can take the column x minus y, x minus y, x minus y. From the row 2 also I can take the common. Y minus z is here, y minus z is here, y minus z is here. So it means from the row 2 also I can take the common as y minus z. Clear? And even I required in the RHS x minus y and y minus z. So therefore I applied this operation. Clear? So now from this I am writing here it is taking x minus y and y minus z, taking x minus y and y minus z common from row 1 and row 2 respectively. Taking x minus y and y minus z common from row 1 and row 2. Just I'll see whether it is visible to you or not. Yes, it's visible to you. So now my students, I'll continue here. So from this, if I take x minus y and y minus z, so you will get here this x minus y into y minus z. So what is remaining here is, here from the in the row 1 it's x minus y common means only 1 is remaining, and from this x minus y is common means only remaining is x plus y, and from this only minus z. Clear? And next my students, from this row 2 I am taking y minus z common. What is remaining? Here it is only 1, and in this case y plus z, and from this minus x. And next remaining third row as it is z square xy. Clear? So next my dear students, next what is required? X minus y I have outside, y minus z also I took. Next term is z minus x. So when we will get z minus x? So z minus x you will get if you z minus x you will get, my dear students, when you will get z minus 2. So here it is row 2 changes to row 2 minus row 1. Here it is 1 minus 1, this will become 0. Row 2 changes to row 2 minus row 1. It means minus x. Here it is minus x minus as it is into this term, that is minus z. So minus x minus minus plus z. So this can be written as z minus x. So therefore, if you apply this operation, you can take a common here. This z minus x you can take common, and even if this element minus this element, then also you will get z minus x itself. So therefore, I am applying this operation. Clear? So here I shown to you why I am applying this operation. Is it? So therefore, now for the x minus y into y minus z, and now here it is r1 is as it is 1 x plus y minus z, and here it is r2 changes to r2 minus r1. Clear? So therefore here it is row 2 changes to row 2 minus row 1. It means 1 minus 1 0. Here it is y plus z, this element minus of this element. What is that? X plus y. So here it is y plus z minus x plus minus minus y. So plus y minus y got cancels, z minus x is remaining. So here it is z minus x, and here it is and minus this element minus this element, minus x minus of minus z. So minus x plus z. So this can be written as z minus x. Clear? If you want, you can take it as rough work. This is all whatever I saw here. This is rough work. Erase this one because you will get confused. So now further row 3 is as it is z square xy. Clear? Now my dear students, you can expand easily. You can expand. If you expand this determinant means you will get remaining as f, you will get this RHS. So before that what I do, again I take here also z minus x is there, here also z minus x is there. So therefore taking z minus x common from row 2. From the row 2 I am taking z minus x common. So therefore here it is x minus y into y minus z. Here it is 1, here it is Z minus x here 0 means 0. If I take Z minus x common means all 0 is there, it will get 0. And next here is x plus y and minus z. The row 1 elements I am writing as this, but I am taking z minus x common from the row 2. Here it is 0 and z minus x means what is remaining 1, and here also it is remaining 1 because z minus x I am taking outside. So here it is, this whatever I am taking outside, that also I should write. So therefore into this into z minus x. Here it is 0 1 1 1 0 1 1 1 I got. And next here it is row 3 is as it is z square x y. Now my dear students, you can observe here in the row 2 you have 0 1 1. So you can expand now along row 1 or row 2 row 3. So whichever is convenient to you, you can apply the common. Usually how to find the determinant value. So like that, by using either you can expand along the row 1 row 2 row 3, or you can expand along the column 1 column 2 column 3, and then further you can simplify. Clear? So now my dear students, what I will do, so now here I am using, I'll expand along, expanding along column 1. I expand along column 1. Clear? And while expanding along column 1, what is necessary? We should change the sign. So this is plus minus plus minus plus minus plus minus plus. Now expand along the column 1. So further, if you expand along column 1 means that I am the continuous part of that I am writing here. So if you wanted to write up to here means please pause the video, then write it down. Next, I am expanding along the column 1. Clear? So to write that part, I am erasing here. So if I erase after expanding by column 1, I will get here. So what is that? Here x minus y into y minus z into z minus x. Now expanding along C1. So therefore plus 1 into. So plus 1 into, leave this column and this row. So 1 into xy is xy minus of this element into this element. Z square into 1 is minus z square. Next 0 and minus into 0, minus into 0 and 0 into anything is 0. So leave that one. Next term is plus z into, again leave this column and this row. So what is remaining? Here it is x plus y into 1, that is x plus y. Leave this column and this row. So here it is x plus y into 1 is x plus y into 1 is x plus y. 1 into 1 into minus z is minus z. But from this element multiplying, we should take another one minus. So minus z into minus, that is plus z. Clear? So my dear students, further if you simplify this, so you will get here x minus y into y minus z into z minus x, and further simplify this, 1 into xy is xy plus minus minus z square into 1 is z square plus here it is z into x is zx plus z into y is zy plus z into z is z square. Further simplify this, here it is minus z square, here it is plus z square. So therefore this can be written as x minus y into y minus z into z minus x, and remaining is here it is xy plus here it is xy, and this I write it as yz plus here it is zx. Just I rearrange the terms and I wrote. So therefore this is what your required RHS part. Clear? So like this you should solve. I think you don't have any notes. Please my dear students, try to practice such type of questions. Then only you will come to know which operation is necessary and which operation you should apply. So that will come by practice, practice, practice. So there is a one saying, so practice makes man perfect. So please try to solve the more number of problems, then you will easily understand the operations, which operation is useful and in which case which operation we should apply. That will come by practice. Clear? Yes. Please pause the video to note it down, and next I will move to the next question. The next question I wrote, my dear students. The question given to you is prove that this determinant value is equals to 2 into x plus y plus z whole cube. Again, this is also very important. To prove this, first what I will do, my dear students. First I consider the, here it is. Consider the LHS. So first I consider the LHS. So what is the LHS part we have? The LHS is equals to here x plus y plus 2z, and here it is z, and here it is z, and here x y plus z plus 2x x, and here it is y z plus x plus 2y. So just I consider the LHS part. So this is LHS part, and now I should prove that this determinant value is equals to 2 into x plus y plus z whole cube. To prove this, my dear students, the operations I am going to apply is, here you can observe here x is there, y is there, plus 2z is here, and but I required, I am taking, I should take the, I should get the in the RHS as 2 into x plus y plus z whole cube. So for that reason, what I do, this here is, here already 2z is there, here x is there, here y is there, here also x is there, here also y is there. So for that reason, what I do, so column 1 changes to column 1 plus column 2 plus column 3. If you add these three, you will get x plus x 2x, y plus y 2y, and already 2z is there. Similarly, here also z is there, z is there. So z plus z 2z, y plus y 2y, and 2x is there. So z plus z 3, and in this case, z plus z 2z, x plus x 2x, already 2y is there. So therefore, what I will do here, column 1 changes to column 1 plus column 2 plus column 3. So therefore, this will become x plus y plus 2z. This element plus x plus y. This element plus this element. And here also z plus y plus z plus 2x. This element, this element, this element plus this element plus this element, that is y. And next here is z plus x plus this element plus this element plus this element. So here it is z plus x plus 2y. And further, my dear students, you can write here this remaining column 2 and column 3 is as it is, x y plus z plus 2x x, and here it is y z plus x plus 2y. Clear? And next you can take the common here, my dear students. In the row 1, if you simplify means you can write it as, so next step I write here this will become x plus x 2x, y plus y 2y, and 2z. So therefore here it is 2x plus 2y plus 2z. And here also z plus z, here it is 2z, 2x is there, y plus y 2y. So therefore 2x plus 2y plus 2z. Clear? And next, my dear students, from this also x plus x 2x. So therefore 2x plus y 2y already is there, 2y plus here is z plus z 2z. Clear? And remaining as it is. Here it is x y plus z plus 2x, and here it is x, and y z plus x plus 2y. Clear? And now, my dear students, from the column 1 I will take, from the column 1 taking 2x plus 2y plus 2z common from row 1. So not from row 1, from column 1 we will get. So what we get here is 2x plus 2y plus 2z, and remaining is here is 1 1 1 1 1 1, and next x, here it is y plus z plus 2x x, and next y z plus x plus 2y. Clear? And now, my dear students, we can see here this from this, or else this right as it is. Here again, to to solve this determinant, only 2x plus 2y plus 2z is there. If I take the 2 common means this can be written as, if I take the 2 common means 2 into x plus y plus z. From this I got here is only 2 into x plus y plus z, but I should require x plus y plus z whole cube. Only x plus y plus z term is there. Again x plus y plus z whole square term is required. That I should get by solving this determinant. So to solve, before solving this determinant, what I told you, here also one is there, 1 1 1. So whenever we have 1 1 1, in that case try to make that row, in which row the row or column 1 1 is there. So that row or column we should convert, we should make the elements as 0. So therefore, for that reason what I do, R3 changes to R3 minus R1, because 1 minus 1 you will get 0, x minus x also will get 0. So therefore I applied this result. So what is that? So 1 x y, row 1 is as it is, and next similarly next row 2 is also as it is, 1 y plus z plus 2x, and here it is y. But now row 3 changes to row 3 minus row 1, this element minus this element, 1 minus 1 0, x minus x 0. Here it is z plus x plus 2y. So here it is z plus x plus 2y minus y is plus y. Clear? And now my dear students, you can solve. Here it is 0 0 is there. It means that I will expand along the column, row 3, expanding along row 3. I am expanding along row 3 because already I told you that in the determinant, in which row or columns maximum, if the maximum number of zeros are there, then that we should expand along that row, because you can easily expand this one, 0 here also 0, here also 0. So we will leave. So we will solve only taking this element. So therefore I am expanding along row 3. It is not the condition that it's not the condition that you should apply you should expand along through the row 3 only. There is no any condition. Either you can apply row 3 or you can apply row 1. But what happens, the steps will be lengthy. So for that reason, in which row or column maximum number of zeros is there, from that row we should expand. And before expanding that, what I told you, first we should change the sign. So here it is, this is plus minus plus minus plus. So here it is, so yes. And next here is my difference, plus minus plus. Clear? Plus minus plus minus plus minus. So now I am expanding along row 3. So if you expand along row 3, you will get. So that continue part I write here. So what happens? Please try to expand that one. So if you expand by regular method, you will get the required RHS part. So my difference, that is I am expanding. So that will become, here it is 2 into x plus y plus z into, here it is plus minus plus. So plus z plus x plus y into, so leave this row and this column. So here it is 1 into this value. So what is that? 1 into, here it is y plus z plus 2x. So this element into this element, minus of this element into this element. So that, and next here it is minus x. So remaining this 0 and anything is 0, 0 and anything is 0. So I am not calculating this. Directly I solved by taking this element. And now here it is, this is equals to 2 into x plus y plus z. And here it is z plus x plus y into, here it is, you can see here y plus z plus 2x minus x. 2x minus x is x. So therefore y plus z plus x. Now my dear students, this element into this element into this element. So we will get 2 into x plus y plus z whole cube. This is what your required RHS. Like this you should solve. So this is your required RHS part. So like this we should solve, my dear students. So please pause the video to note it down. So these are all very important questions that I solved. So still some more questions, some more problems are there in your NCERT textbooks, so that you should solve yourselves. But these are the very important. Still, if you have any doubts in these type of questions, you can comment me. I will reply for that. Clear? And now we move to the next concept, that is how to find the area of a triangle by using determinant method. That we are going to discuss in the next video. Thank you.